Today we're doing Math 6, Mission 6, Lesson 8, Equal and Equivalent. So let's use diagrams to figure out which expressions are equivalent and which are just sometimes equal. So we'll have things that are always equivalent no matter what. And then we'll have equations that are equivalent sometimes, but that's really not equivalent, that's just equal. Like, it happens to work out that in this specific situation, they're equal to each other, but they're not always equivalent. Okay, so we're gonna go through and do that. Find a solution to each equation mentally. So 3 plus x equals 8. Well, I would do 8. The opposite operation is subtraction, so I'd do 8 minus 3, which would get me 5. So I'd look 10 equals 12 minus x. Well, I can look at that and say 10 to 12 is 2, so I'd have to take away 2 to get to 10, right? X squared would mean x times x is 49. So like 4 squared would be 4 times 4 equals 16. So what times what equals 49? The same number. And I know my math facts, so I would know 7 times 7 equals 49. And then here, this is 1/3 times x equals 6. So I can do the opposite operation. So that's dividing by 1/3, dividing by 1/3 on this side as well. So I know 6 divided by 1/3 is keep, change, flip. So I would do 6 times 3, which is 18. So x has to equal 18. Okay. All right, draw diagrams that show. Here we go. So we have 2 plus 3. So I have 2 plus 3, 1, 2, 3, and 3, 1, 2, 3, plus 2, just like that. So this is my 2, this is my 3. 3 plus 2 and 2 plus 3 are always going to be equal because they start and end at the same spot. That always works, okay? Let's go on to this. 2 plus 3 does not equal, so 2 plus 3 does not equal 2 times 3. All right, here we go. We have 2, so here's my 2, plus 3, here's my 3, okay? And then I'm gonna do 2 copies of 3. So here we go. 1, 2, 3, 1, 2, 3. So I have my 2, I have my 3, and I have 2 copies of 3. If you notice, they start at the same place, but they end different places. So they are not equal. So we need to understand there are differences in addition and subtraction, etc., right? And multiplication and division. All right, let's look at some examples here. Answer the following questions. Here's a diagram of x plus 2 and 3x when x is 4. Notice that the two diagrams are lined up on the left side. So here, we have them lined up, okay? Okay, and it says x equals 4. So you can see we have x to 4 here plus 2. Here we have 1, 2, 3, 4, one group of x, 1, 2, 3, 4, another group of x, 1, 2, 3, 4, another group of x. So that's 3 groups of x, okay? So let's keep going. In each of your drawings below, line up the diagrams on one side, okay, just like they did up top. So here we go. Draw a diagram of x plus 2 and a separate diagram of 3x when x is 3. Okay, so x is 3, so I'm going to substitute that in here. So it'd be 3 plus 2. All right, here we go. So we need a group of 3, 1, 2, 3, and a group of 2, 1, 2. So that's my 3 plus 2. And, oh, you know what? I'm going to say this. X is 3, so I'm going to say this is x and this is 2. Now I have 3x. So remember, x is 3. So I need 3 groups of x. So here we go. Woo. 1. This is what I wanted. 1, 2, 3. So again, I have x and another x and another x, right? So you can see I've lined up this side, but this side does not line up. So these are not equivalent and they are not equal. Draw a diagram of 2 plus x and a separate diagram of 3x when x is 2. All right, so here we go. So we have x is 2, so I'm going to do 2, and then I'm going to do another 2, because this is x and this is 2. Then I'm going to do x 3 times, 3 groups of x, and x is 2. So we have 1 group of 2, 2 groups of 2, 3 groups of 2. So again, we have x, x, and x. So they are lined up on one side, but they again are not equal or equivalent. All right, let's go on to the third one. Draw a diagram of x plus 2 and a separate diagram of 3x when x is 1. Okay, so x is 1, so we've got that. And then we have plus 2, so I need a group of 2. So this is x and this is 2. Then I'm going to have 3 copies of x and x is 1. So here we go. 1, 2, 3. Again, I have x, x, and x. Now look, this side lines up and this side lines up. So when x is 1, these two equations are equal, but only when x is 1. Well, let's see, because we have x is 0 left. So draw a diagram of x plus 2. Well, x is 0, so I wouldn't have anything for x. I would just have a 2 like that. And then for 3x, well, 3 times 0 is 0, so I wouldn't have a diagram. So again, these are not equal. All right, when are when are x plus 2 and 3x equal? So only when x equals 1 are they equal. When are they not equal? Well, when x is 4, 3, 2, 0. Not equal, x equals 4, 3, 2, and 0. Right? Because our diagrams show that they don't end at the same spot. Okay? Draw a diagram of x plus 3 and a separate diagram of 3 plus x. Okay, so we will have some distance of x, we don't know what it is, plus a distance of 3. Okay? So this is x, and this is 3. Now I'm supposed to draw a separate diagram of 3 plus x. Okay, so here's 3, and here's x. So again, because they have the exact same numbers, right, just in a different order, and it's addition, and you can add in any order, they are going to be equivalent every time. No matter what x is, x and that number are always, or this equation, x plus 3, and this equation, 3 plus x, are always going to be equivalent, no matter what x is. So when are x plus 3 and 3 plus x equal? When are they not equal? Well, they are always equal. They will never not be equal. Okay? All right, let's keep going. So we are going to look at a list of expressions. Find any pairs of expressions that are equivalent. Equivalent. If you get stuck, try reasoning with diagrams. All right, so we have a plus 3. So I'm going to go through here. A plus 3 and 3 plus a are the same things, right? If a is 4, 4 plus 3 is 7, If A is 4, 3 plus 4 is 7. Doesn't matter in which order they go. So those two are equivalent. Let's look at another one. All right, let's go here. A plus A plus A is the same. Remember, multiplication is just repeated addition. 3 copies of A times 3 would be the same thing. 3 times A is still the same thing, right? And this one right here, A divided by 1/3, we keep, we change, and we flip. That is A times 3. So that also is an expression that goes with the other 3. Okay? Now we have 1/3 times A. And 1/3 times A is the same as doing A divided by 3, because 1/3 times A, we could do A times 1/3, and we would keep, sorry, not keep, change, flip. We would do A times 1, which is A, and then 1 times 3, which is 3. So A over 3 is this one right here. So they match. And then finally, we have our last one, 1 times A and A. Anything times 1 is itself. So those two go together. Okay? Now, finally, it says, write an expression that is equivalent to each of the expressions below. So when we have like terms like this, we can combine them. So we can combine like terms. So see how this is addition and we have 3 times B and 4 times B? That can be 7 times B because it's still copies of B. Now this, we can multiply in any order. That's there's a property of that, right? So that means I can do 6 times 3, which is 18, and I can do 18 times B, and that works. Or you do what's in the parentheses first. Okay, 6 times B is 6B, times 3 is 18B. All right, here again, they're all B's, so we can add them together. 2, 4, 6, 6 copies of B, right? Because this is really B and another B plus another B and another B plus another B and another B. So that's 1, 2, 3, 4, 5, 6 copies of B, right? That we add together, right? Because remember, multiplication is just repeated addition. All right, now here we have 7B, we have 3, and we have 2B. We can combine the B's together. We can't combine the 3 though. So we have 7 plus 2, which is 9B plus 3. So B times 3 is the same as doing 3B. So we can do that. 5B plus 2 plus 5B. Well, 2 and 5B we can't combine. So we've done what we can in there, and now we can take it out of the parentheses. So we have 5B plus 5B, which is 10B, because we're combining like terms, plus 2, our 2 that's left over. And then finally, we have 2B plus 3C plus 4B. Well, we can combine the B's, but we cannot combine the C, okay? So 4B plus 2B is 6B plus 3C. Because B and C are different variables, we cannot combine them, okay? Please make sure you review your lesson summary.